All right, welcome to our Hot Glass Show. This is a really special evening for us. I'm going to introduce our team, starting off with our featured artists here. We've got Michael Schunke and Josie Gluck. Let's give these guys a nice warm welcome and an excellent round of applause. They're here actually teaching a 2-week workshop at our studio right across the parking lot. But here, this is our amphitheater hot shop. We've had this open and running for a few years now. We've got our own core team that's going to jump in and give a hand. Actually, we do have Ryan. And Ryan, I'm sorry for your last name. Thompson. Ryan Thompson's here. He is a TA, teaching assistant, with Josie and Michael. And then we've got G. Brian. He's the one that's got some glass in the pipe. Dane Jack. My name is Chris. We've got Jason, who's going to be doing some video, getting some good close-ups. And, of course, our live stream audience. So this is a live streamed event, our late show here with our visiting artists. So we've got the internet that's out there tuning in, too, as well. So Amanda's over here, and she's going to be fielding all that online activity. So I'll talk you through the process. This is going to be a very in-depth glass blowing demonstration. And of course, every piece that we usually create starts off with gathers of molten glass. And that's what G has on the end of a blowpipe. So you can see that he's taken this pipe, he's dipped it into a furnace, and he's taken a pretty good collection, or we call it a gather, of glass. And here's where the blowing process begins. A breath of air trapped in this pipe. This is a stainless steel tube. And that air pressure that he's just put in there is doing its work. It's going to push against the barrier where the glass meets the pipe, and eventually that pressure wins. As long as the glass is hot enough, it's very, very soft. And that air works its way into it and forces a bubble to expand. Now, this is the starting point for literally almost any blown object. And this is clear glass as well. We have a lot of equipment up here. Our main furnace, which is going to see these guys go to quite a bit, is right center stage. We have a door on it. And that's running at about 2,100 Fahrenheit. So the glass inside that oven is very much liquid. In fact, it's a lot like table honey in consistency. Does anybody know what glass is made of? Shout it out if you know the main ingredient. Sand. Yep, I think I heard silica, sand. Those are both correct. Silica sand, that's the primary ingredient to any glass in the world. Now, we're working with what's called soda lime. Soda lime glass is very average. It has silica sand, soda ash, and limestone. A bunch of other ingredients, but that's the main mix of it. And when you mix those ingredients together, that's called batch. And batch is very, very fine powder. In fact, these are the ingredients right here. You can see the silica sand, the soda ash. It's not like beach sand, right? This is very, very fine. Beach sand could melt down, but there's many impurities in there, like chunks of dirt and shell and rock, that wouldn't melt down nicely the way that we want our glass to work. So the silica sand is very, very clean. It's very refined. Now, we got all this stuff ready, all these different tools that we're going to use to work with and create this beautiful bowl. They have a bowl in mind. And Michael has brought with him, Michael and Josie brought this mold that we're going to use at the very, very end of the process. So it's just, I think that's paper, right? Layered paper on top of like screen or mesh? Okay, wonderful. So we're going to see that mold in action. Now, there's a lot of materials that we can use as shaping tools and devices. And we use a lot of wooden tools as well, like this one. This is a wet wooden scoop. These are called blocks. And you can see these come in a variety of sizes. So as we take more gathers of glass, we need a larger block to accommodate shaping it, and they come in variable sizes. Now, it is important that these blocks are saturated with water, soaking wet. The fruit woods that we use, I believe most of the ones we have out here are cherry wood. They hold the water really well, so we get them waterlogged, and all that water turns to steam, and it stops the glass in the wood from sticking. If you tried to use a piece of dry wood and molten glass, it sticks to the wood right away. It does not work well. Fruit woods also burn away very clean, and they burn away very slowly. So 3 wonderful attributes as glass-making tools. Another item that you'll see the guys use here is this. This is folded up damp newspaper, also soaked in water until it's pretty wet all the way through. There's many, many layers of paper. In fact, when we fold up a paper like that to use, we usually take about 2 full sections, maybe 3 full sections, and fold it up into a square, soak it in water. And that's actually 2 of those papers. Michael said that he wants a backup on that. It does get warm if you use it for a long, long time, especially with a lot of glass. And we're going to see a lot of glass on the end of the pipe here before the night's over. So our reheating furnace, this is an empty oven. There's no glass inside this one. This is just what we use to reheat whatever we're working. And isn't this an excellent shot that you're getting right now? There's no camera in the furnace. I know it looks like it. But our camera's safely mounted behind it. And we have a very small window of pure silica glass. It's called fused silica. And that glass has a melting temperature about 3,000 Fahrenheit. And that furnace is running about 2,000 Fahrenheit. So it's not melting the lens at all. That window protects our camera. But this paper gets us about as close to shaping with our bare hands as we can. And that's why glass makers really love to utilize it. Very simple tool, very effective. This is a common move to get some help from your assistant inflating the bubble as the lead glassmaker is shaping it at the bench. So I'm going to use the term gaffer, and gaffer is what we like to use for the lead glassmaker of the team. That's the term that we apply to it. Now, in this case, we have a team of many different glassmakers, and that gaffer is the one that orchestrates everything. They're the one that's really in charge of the process. Now, you could have a lot of different components happening at one time. Our shop is really well situated to do that. But that gaffer is the one that's really running the show. I do like the term orchestra because if you have a conductor to an orchestra, you might have 30 band members in it. That conductor really is in charge of the timing, the flow, the rhythm, all those things, which are always present in glassmaking. So over here, we have, this is going to be a wrap, I believe. Now, Michael and Josie have been here more than once. They've actually taught classes at the studio many times. But they were here as visiting artists for at least a week with us. I think it was last year. It's hard to remember everything. It sort of blends together.
Yeah, they were here
the end of last February and the beginning of March. And they were making a series of really beautiful bowls. And I remember seeing some prep work like this, like what Josie has going on, that's going to be a decoration for this bowl. So we've got a couple layers of clear glass right here. This is sort of the base. This will be the interior of the bowl. And Josie has little strips of glass cane. These are just all white. Can I see one of those? I'm gonna take a look. Yep, I got you one. Thanks. So this right here, this is glass color, and then just white. Now, when we start off with color glass, we usually have what's called rod, and this is a lot of different colors that have been blended together, but this will serve its purpose. So color bar or rod is produced by a few big factories around the world. We buy ours that we use here from the Reichenbach factory over in Germany. But they make hundreds of colors to work with. So imagine that this was just one big white bar. You could heat this up and you could put layers of clear glass over it to give you more material, and then you could stretch this as long as you wanted to. You could stretch it thinner and thinner and thinner, get the desired thickness, let the glass turn rigid, and then you can chop it up into individual pieces, and that's called cane. There are many ways to use cane. There's a lot of different ways that you can apply it. And what they've done here is laid, looks like about 6 or 7 of these onto a metal plate over there, which they heated a little bit. And then they had a little cylinder of clear glass that they rolled over the cane to put little stripes over it. And this is going to be a wrap. We're going to wind this around the bubble of clear glass that Michael has. So before we started, he got this roller wrap device all situated. And these rollers can pivot. They can turn to give us a much tighter tracking pattern or looser, depending on what you want. So he got those in position where he wanted them earlier. You can see he was just giving a little dry run there with the bubble. And now they're simply in a holding pattern. So G's going to keep that bubble just the right temperature. We don't want that bubble moving at this point. Before we apply the wrap, we don't want that to be too soft, because as they turn it, if the bubble's really soft or hot, it'll kind of start to wobble around. And you'll get the idea what I'm talking about here in just a moment. So we talked about the formula of glass, right? The batch, the silica sand, soda ash, limestone. When you add different metals, metal oxides, metal chlorides, and melt those ingredients together, you will change the color. So white, I believe, comes from titanium or zinc. Antimony alloys will make white glass. Cobalt makes a rich dark blue. Iron oxide makes it green. Copper makes a nice light teal blue, so on and so forth. So we have 2 different reheating furnaces. The one that Josie's working at is a little bit smaller than this one. And we've got a really big reheating furnace too. The team won't need it for this one, but you can see right over here, this one has an extra set of doors on the very exterior. And if we open that up, yeah, thank you very much, Ryan. Check this out. We could fit probably 5 of us in there if we wanted to. That's a really big reheating oven. Now, the standard one that we're working on today has 2 burners that are positioned. If you're looking at the face of that from where you're all seated as a clock, right at about 10 o'clock, there's 2 burners that fire natural gas and force air into it. That larger one has 4 burners, and that's a very significant difference in terms of energy, for one, that it takes to run it, but also the amount of space that you can work into that. But for the size bowl that they're going to make today, the standard reheating oven is punty. So for this wrap, this is going to get spooled around the bubble. We want this to thread on there very evenly. So the way that Josie's been preparing this is getting the heat just right in that little gather with those little strips of cane in there. And she's pointed it up, too, quite a bit. If you imagine an artist taking a pencil and sharpening it to a very fine point to draw a very, very thin line on paper nicely, we've basically done the same thing with the glass. We've pointed it up. We've almost sharpened it, so to speak. And you'll really enjoy this. This is a lot of fun. Can we get an overhead zoomed-in shot on that bubble? Oh, wonderful. Thank you very much. So this is a nice shot right here. Now, they've set up a yoke. When Josie gets her gather glass right over here in position, she can set it on the yoke and remain in one position, and then the tracking machine will do the rest of the work. Here we go. And Michael starts to spin pretty fast for this. And see, so you get the idea. The tracking machine is doing exactly what it needs to. She's got the wrap in position. She doesn't have to move it herself, and we get this perfect machine thread all the way down the bubble. Let's give them a round of applause for that. I love watching such a smooth application like that. And if you see something that you like, let them know. Just cheer for them, give them a good round of applause. And we'd like to keep the excitement going here. You won't scare the team, I assure you. And if you have any questions, too, just shout them out. Get my attention. That's what I'm here for. And people online, if we have people online, they'll field a question through Amanda, and I will answer it as these guys work. But Michael is a very skilled glassmaker. A common question is, how long does it take you guys to learn to blow glass? And I usually tell people it's about 5 years, give or take, to get the basics, just to get those basic set of skills to the point where you're comfortable turning the blowpipe with a couple gathers of glass on there. But then obviously to get much more skill, takes many, many more years. If you think of it like playing an instrument, I like that analogy because it takes a few years to get the muscle memory down, just to turn the blowpipes smoothly to the point where you don't have to think about it anymore. But then there's such a wide range of skills that you can really keep working at and enhancing. And Michael's been blowing glass for, let's see here, I'm going to guess it's about 30-some years. Michael, how long have you been blowing glass? I can't remember. 29 years, just about. I was very close. 29 years. And it shows. He is extremely skilled. Very, very gifted glassmaker. So you'll see him use this table quite a bit. This is called a marver. This is just a giant steel table, a very basic instrument, but a very useful one. We have a couple different marvers, too. We have a smaller one that Josie was using over there, but this one's pretty big. Now, we can use the flat surface as a shaping tool, but we can also use it as a heat sink. Now, at times, you want to draw temperature from the glass. And I'll reference that again. I'll come back to that point later on. But let's just remember that any material we use to shape the glass with is essentially drawing heat from it. When you touch it, that tool absorbs heat. And the metal is an excellent heat absorber. It really pulls heat from the glass. So does this. This is compressed air. Just like you might blow air onto a hot cup of soup to cool it down quickly, or a hot cup of coffee, we can use that compressed air to do the same thing. So they are going to wind this wrap around here more than once, maybe 3, 4, 5, 6 times. I'm not sure. A lot more than that. Many, many times, he says. Okay. And again, this is going to be the interior of the bowl. So after we get this next application on here, I'm going to see if I can find a piece that will explain what I'm talking about a little bit better. We have a bunch of pieces down here on our stage. He does have a cup with him, a very large cup, not one that you would drink from, but a color cup that we have gotten to an oven and prepped when the time comes to apply that. So we're going to work with another color on the outside of this. So this wrap has to be prepared just right. If the heat is wrong, it can stretch out very, very thin, or it can pull off from that rod. So really getting just the right setup in that wrap before applying it. And Ryan is using just a little MAP gas torch to burn the very tip of that, melting it away so it just simply burns right off. And then Josie has more material that she can work with. So the interior of this is going to be clear with the thread reps. We don't really have a piece out here that's going to show you exactly what I want to, but let's use this. So any blown form, when we start off a blown form, it's on a blowpipe, typically. And this vase has an interior of all white. Then there was actually a wrap of blue glass that was spooled around the same way that they're doing right now. Once the wrap was on there, I think this is Tom's piece, he took a pick and dragged the surface in many places to create what's called a festooning effect. And if you go the opposite direction, you can go this way and that way, it's called feathering and festooning. So the exterior of this had the wrap on it, the interior did not. So in this case, with this bowl, the interior has the wrap. I don't think he's going to feather and festoon this, but the interior is going to have the threads of the white glass on there. The exterior is a transparent gray layer. So he's already made what's called a color cup. And again, it's not a cup that you would drink from. You could, but it's a very big one. It's very thick and heavy. So basically, if you imagine that this was just all one solid gray color, just think about that, and it's a cup. This is sitting inside of a pickup oven right now, and it's resting at a safe temperature of about 900 Fahrenheit. Now, when the time comes, he's going to take this gather of glass, he'll probably get more glass on top of that, and drip it perfectly into the center of the cup. He's going to fill that cup. And then he'll pull that out of the oven, and it'll have a perfect veil of gray glass on the outside. Does everybody follow that? So we'll have that wrap pattern on the inside, but then we'll have a nice layer of transparent gray on the exterior. When I say safe temperature of 900, when we talk about our glass, at about 2,100 degrees, it's just like table honey in consistency. Once it reaches about 1,000 degrees, it's rock solid. It's as hard as these window panes. If it drops below 900 degrees too quickly, what happens to it? It breaks, it cracks. Yep, so thermal shock, it's something that we have to be very careful to avoid. So that safe temperature of 900 is fine to keep that cup stable and rigid. We don't want to turn that oven up too much just yet, because if we cranked it up to, say, 1,200, that's right above the melting point, that cup's going to start to slowly distort its shape. We don't want that to happen. So we'll keep it at 900 until we get close to stuffing the cup, and then we'll turn that oven up just a little bit, just to get the heat into the form so it's not in danger of shocking. Yeah. Gotcha. This is Duro, yeah. Right. So Michael's saying that a lot of what the back and forth that he's doing right now, he's cooling this, he's heating it, he's cooling it, he's heating it. I know it doesn't appear like much is happening because the shape isn't really changing or anything, but he's melting the texture of those wraps away. When those wraps go on, they leave ridges. And if you leave too much texture and then you go to put another wrap on there, sometimes that secondary wrap will create air bubbles in between the two, and they don't want that to happen. They want to keep this nice and clean, so they have to take their time and let it get cold, quote, cold, rigid, and then reheat it, and the core sort of stays in shape, and then that surface gets melted down really nicely. So again, more terminology. When we're talking about temperatures and we say hot, we say cold, we just mean fluid and rigid. So fluid is 2,000 degrees, rigid is 1,000 degrees. So that's what I mean when I say cold. They're letting it get cold. They're letting the core stiffen up. But to save anything, since we can't let it cool too rapidly below 900 degrees, we have to slowly cool everything. When this piece is done, it is going to go into an oven called an annealer, where it will slowly cool. A piece like this, probably 24 hours, maybe 36 hours. I'm not sure. It's up to Michael how long he wants it to go. But most of these other pieces that we've made throughout the days here, something thin like this, 8 to 10 hours of annealing is fine. It's really based on thickness of something. So the thicker something is, the longer that annealing cycle has to be. One of my favorite pieces in our museum is actually the largest piece of glass here. Does anybody know what it is? It's 200 inches in diameter. The big disc, yeah, the big disc that was cast here in Corning in the 30s. It was going to be used in California, in Palomar for the observatory. The disc broke when they were casting it because the mold failed, but they were able to save it. They annealed it, and then they reinforced the mold. They cast it a second time. It's over 40,000 pounds of glass, so it's about 20 tons of glass, and it had to anneal for 11 months. Almost 1 year to slowly cool an object. I can't imagine waiting that long. But a giant piece of glass, one single object, just over 20 tons. Okay, so they're getting more cane ready. So what Ryan's doing, Ryan's got a big pair of forks. Kind of looks like pitchforks. We call them pastorelli forks because we can pick pastorelli plates up with them. And plates are just either a ceramic shelf or, in this case, a metal plate that they have laid out those strips of cane that they need. And before you roll a cylinder of glass over the cane have to be hot. They have to be hot enough to actually stick. And it looks like Dane is getting the gathers for that next wrap going. So our furnace has the ability to hold 1,000 pounds of glass. The crucible that's in there, the ceramic crucible that's in there, will hold 1,000 pounds. And right now, it's not totally full. It's probably got about 800 pounds, maybe a little bit less than that in there. And you can hear when they open the door, the burner actually idles back a little bit. If the burner was blasting the whole time and you dip the pipe in, all that exhaust comes right out at you, and it's a little bit uncomfortable. So that is a really nice furnace design. Actually, this whole shop was made by Spiral Arts, a company out on the West Coast. We've had them create a lot of equipment for us. And that is an excellent furnace, and one of the most comfortable ones I've ever worked out of. When you open the door, the burner idles back. It's very comfortable to gather. When you close the door, you can hear the burner kicks on again because it's trying to reach its temperature again, its set point temperature, which right now is actually at 2120 Fahrenheit. And you can turn it up or down depending on what you want to do with it. So if we were, say, casting glass, if we want to take big ladles and dump them into a mold and have that glass really pour nicely, you want the viscosity to be a little bit less. You want it to be not as viscous. So you want it to be more runny, and you can turn it up to 22 or 2300 Fahrenheit. But if you get too hot, then the glass is too hard to gather out on the blowpipes. And on the flip side, if it's not warm enough, then it's very viscous and it's hard to gather. So if you think of table honey, get a bowl of honey and dip a chopstick into it, try to collect some honey on the end. That's kind of what we're dealing with. If you were to put that bowl of honey in the microwave for about 30 seconds and do the same thing, the viscosity changes quite a bit. Or if you put the honey in the refrigerator for about a minute or two, it becomes pretty stiff. So he's making sure to keep that interior bubble. Can everybody still see the bubble? Right? If you look up on the screens, Jason's getting a wonderful shot here. You can see that bubble still has a nice even thickness. And as he is rolling this on the table to sort of squeeze those wraps down to the surface, the more he does that, the more condensed that bubble gets. Now, if he did it too much, that bubble could actually just collapse, or it could just disappear. It could recede all the way. So sometimes you'll see him, he kind of did that little blow and cap method. He put a little pressure in the pipe, kept it there with his thumb, and rolled back and forth to keep the volume in the bubble while he's doing that. That's a pretty finesse move, too, to do that nicely. When a good glassmaker marvers, this is called a marver, this table, so we call that act of rolling back and forth marvering. When a good glassmaker is marvering, they make it look so easy and effortless. Like you just set it down and then it just rolls itself. It is not the case at all. You really have to apply a lot of upwards pressure to stop that bubble from flattening. Because if you come over to the table and just set it down, even for a split second without rolling it nicely, then you're going to create a flat side on it. And then if you get a flat side on there, it's very hard to correct that. And you'll see him use the marver quite a bit for this piece, I'm sure. So you got lots of cane, and as they get the next wrap going, the next wrap on there, you can see that they're now preparing some more cane. So this plate is pretty hot right now because they've just been reheating it. But these little cane are pretty narrow. They're about the diameter of a pencil. So you can put them onto a 1,000-degree plate, and most likely they're not going to crack. Now, if you took that bar that I had, this is pretty thick. If you took this and you set it on that plate at 1,000 degrees, what do you suppose would happen to it? This would probably explode. It might take a few seconds, maybe 10, 15, 30 seconds, but this is surely going to crack. This is too big. You got to soak some heat into something that's bigger like this a little bit slower than something that's much smaller than that. Kind of the same concept of annealing. You have to slowly heat something. And if we took any of these objects and we wanted to rework them, we could slowly heat them back up and then get them on the end of a pipe again and do that. It's very tricky to do that, but you could. Has anybody had a glass break on them that they've put in the dishwasher or maybe poured really hot water into for tea or something like that? So our soda lime glass does not like that rapid temperature change. So it makes it very bad for something like that. So if you want to use a mug for coffee or tea, it needs to be the right type of glass. Has anybody heard of borosilicate? Anybody heard of Pyrex? A lot of people are shaking their head yes when I say that. So Pyrex is a brand name for a type of borosilicate glass. And when you mix those ingredients together, you add boron to it, that lowers the thermal expansion of the glass, which basically means it can handle rapid temperature change and not break nearly as much as soda lime would want to. But the soda lime glass does not like that. Yes? How many wraps? I think that was the third or fourth. I'm not entirely sure, but yeah. I think we're going to do a bunch. They were just prepping some more cane on there. They got lots more cane here. And Michael, this is going to be a pretty thick piece, I'm assuming? Thick-ish. So I'm only saying that because I remember working with Michael and Josie when they were here last year, and they did a lot of different patterns with these bowls, but I remember the interior layers had a lot of layers and layers and layers and layers, and they left them pretty thick in certain parts of the bowl so that when you looked at the bowl, the interior, you could see the depth of those layers. So if you were to do all this layering and then you blow the glass too thin, you can't see that depth anymore. It just sort of flattens everything out. So in certain cases, leaving some extra thickness when creating all these layers makes a really nice effect. And from time to time, you'll see these guys come over to this, the pipe cooler. This is just a water pipe cooler. And again, the stainless steel, not a good conductor of heat, but it does get hot. So to give us more leverage when we're holding the blowpipes, we can cool off most of the pipe and give ourselves a better handle on it.
It's a little tedious right now. But
Yeah, no problem.
it's working.
Yep, it's a beautiful effect. Any other questions out there? Yes. Say again? The mitt. Oh, this is newspaper. Yep, this is folded up wet newspaper. Yeah. That one was the Wall Street Journal. Yeah. Now, there's lots of, I mean, you can use whatever paper you want, right? But certain papers, I think a lot of glass makers will tell you that some, if you're making a very loose or progressive piece, you use the New York Times, Michael says. Wonderful. But certain paper has, you know, better quality. I think it holds up better than others. I've worked with some paper that you get it wet and it just sort of breaks down. It kind of turns to mush. And you obviously don't want that to happen when you're shaping molten glass with it. So paper that has, you know, a little thicker quality to it holds together better under these conditions. Because it's getting steamed too. You know, when you're shaping hot glass, you're going to see some smoke come off from this, but all the water that's in here is going to turn to steam. And that's basically what prevents the glass from sticking to the tool. It's the same concept as using these wooden blocks, these scoops soaked in water. We never let these dry out. You want them to stay wet, nice and wet the whole time. Now you can see there's very subtle movements too. When Josie brings this over, she tags it down on what's called the moil of the glass, which is going to become scrap material. The glass that's actually on the pipe itself, that's just part of the process. And it's not actually going to be part of the bowl. So that's where she tags down the wrap, and it sort of leaves a little blob right there. And then as they start to track, she's got, you know, just a couple seconds to pull back or get in the right position of thickness with the wrap as they start to trail it all the way down. It's really a very time-sensitive thing to do that. But always tagging on the moil first to get that blob of glass up there, because that will turn into scrap material. We begin by preheating the pipes, actually. I'm not sure if anybody was here before G took his first gather, but we have a pipe warmer over here. You guys on this side can see into that pipe warmer. Thank you, Ryan. That orange glow, that's actually electrical elements. They're heating ours. Most studios use gas, use combustion for their furnaces, and most studios, I believe, still use gas-fired pipe warmers. Now, this is an electric pipe warmer. This is something that we started to work with about 10 years ago. Our museum had partnered up with Celebrity Cruise Lines, and we had 3 shops that were all electric shops installed on 3 of Celebrity's cruise ships in their Solstice class fleet. Has anybody sailed on cruise ships before? What's one of the biggest concerns, their safety concerns out there? Fire safety, right? So fire safety being a very big concern for a very good reason on a ship. When they asked us to look into the idea of putting glass studios on their vessels as demonstrations, they said, well, we can't have open flames. So can you guys figure out a different way to use a shop? And an electric shop, an all-electric shop was invented for that. And that electric pipe warmer, that had been the first one I'd ever seen working on that program. And it works great. You get it just to the right temperature. A lot of times with a gas pipe burner, you get a lot of soot on the tip of the pipe, a lot of carbon buildup on the pipes. And if you dip the pipe into the furnace with a lot of carbon buildup on there, it gases off and lots of little bubbles form right off the end of the pipe and they get into the glass and it's a mess. So the electric pipe warmers are really, really nice in avoiding that. We actually still have the model. The first ship, yeah, so right behind the seat here, if you guys, when you leave the theater, you're welcome to walk around this way. There's a giant case over there with a model of the Celebrity Solstice. That was the first ship that we were on, that electric shop. And you can see it's on the top deck towards the back aft of the ship. And you can see that the model of the shop is right out there. It was a great program. Actually, G, Dane, myself, we were all out there for many, many contracts. But again, this amphitheater hot shop, this has been running for, I think we opened in 2015, March 2015, we had our grand opening. And this building, the framework, if you look up, this is all the original framework for what was the Steuben glass factory. Everybody familiar with Steuben glass? So it operated right here for many, many years. Steuben still exists, but it's not the same as what it was. The factory no longer, but there is still a Steuben product that's being made. The factory had shut down, and when it did, the museum expanded into this area. So this amphitheater and the contemporary design gallery that many of you probably walked through to come in here was part of our North Wing expansion. And I believe that the whole expansion, this North Wing expansion, was basically the same size of 1/3 of what our museum was before we expanded into this. So a pretty significant add-on. Any other questions? All right. Well, if you do, just shout them out. Get my attention. Throw your hand up in the air. 4 or 5 more, Michael says. 4 or 5 more wraps. You want that bumped up? You want it to like 950 or just 930? 930. So we're going to start to kick the temperature up in this cup little by little. We don't want to do this too soon. So 900 degrees, that's where this glass is totally rigid. And the type of glass that he's actually working with, so across the parking lot at the studio, they're working with soda lime glass too, but they're actually working with batch over there, which are the raw ingredients. They melt down the raw ingredients, and they do it very safely. But that glass is a little bit softer than what we have. What we're melting is cullet, which has already been melted once and turned into little chunks of glass. So the batch is a little bit softer. So if we get our temperatures off a little bit too much and turn that up too soon, the cup can actually either distort its shape or it can stick to the ring that we have it sitting in. So it's sitting upright in that oven. So we definitely don't want either of those things to happen. But I'd say the worst case scenario is if we didn't have that cup warm enough and we open up that door when the time comes for him to dip the pipe into the cup, cold air is rushing in, and that cup could crack if it's not the right temperature. And that would be the worst case scenario because that's, you can't fix that. You could melt it back together, but you're going to have all those cracks will create lots of air bubbles, and it will just ruin the whole thing. So Michael's got to say hi to his mom. Is your mom watching right now? She's watching? Yeah. Where's she watching from? Tampa, Florida. All right. Carol Peeds. Peas. And then Arlene Gluck from Concord, Massachusetts. So big shout out going to both of you. From Michael Schunke and Josie Gluck. All right. Amanda, do you know how many people we have watching right now? 36 on Facebook. And 119 on YouTube? Nice. And if anybody wants to let a family member or a friend know, certainly hop on either of those social media channels and check that out. I know if I'm out of town, I'll tune into the YouTube channel. If you just go to CMOG, type that into the search bar in YouTube, it'll pop right up, Corning Museum of Glass. You'll see our official page there. And all you do is click on it, and you'll see the live feed box right there. You can watch it very easily from any device as long as you have internet signal going to it. And further down the line, too, not just tonight, but we do this guest artist series all throughout the summer, and we have guest artists throughout the entire year. There's a lot of programs that we have going on here throughout the entire calendar year, and we live stream quite a few of them, as well as just post, videos, footage, photos, and blogs about a lot of activity here at the museum. One very special thing that I will highlight right now, is anybody local to the area within an hour drive or so? A couple hands going up. This is a really special year for us here in Corning. This is our 150th anniversary year of glassmaking coming to Corning. And that story actually starts in Brooklyn. So in 1868, a company called the Brooklyn Flint Glass Company made the move here to Corning. They were convinced to move their company, which was operating in New York City, to Corning, New York, and start their business here. So when they made the move, they took all their equipment, their machinery, their tools, they loaded it up onto barges, and they towed those barges through the canals of upstate New York to get their equipment here to Corning. And it was offloaded just literally about a mile down the road, right near where Gibson is now. And so to celebrate that, we have a few things that are going on. The biggest thing right now is an outreach program called Glass Barge. Anybody familiar with this? A couple heads nodding. So Glass Barge is an electric shop, the same type of shop that we had on the Celebrity ships, and it's been fitted onto a barge. We started it in Brooklyn, New York, just a couple blocks from where the original factory used to be, and we were doing glass blowing demonstrations there for a couple weeks, and then it started to sail its way up the Hudson, and eventually it's going to make its way to Watkins Glen throughout the 4-month course that it's going to run. So it's celebrating the 150th anniversary by basically retracing the steps that the barge took 150 years ago to get the equipment here. But we're doing glass blowing demonstrations to really bring that to all the communities that we're stopping at. I think about 30 different stops. We also have a Crystal City Gallery that has just been revamped and reopened in our 35 centuries of glass. Anybody seen that? Definitely check it out while you're here. You don't want to miss it. It's beautiful. It's not a brand new gallery, but it's just been freshly revamped. And all the objects that curator are wonderfully displayed. And it tells the story of how glassmaking came here. There's a new exhibit, too, Glass of the Architects, brand new exhibit that is in that same 35 centuries area, glass from Austria, and that's stunning as well. So you can check out both of those while you're in that area. And if you want your passes today, they're still good for tomorrow, so remember that. Come on back. Any other online questions, Amanda? No? All right. Yes. Yes. Flint glass, I'm not exactly sure of that, and I don't want to step into deep water with that, but I know the Flint Glass Workers Union, so a lot of terminology there that's similar. Yeah, I don't have a great answer for that. I should, but. But I will say that when Corning Glassworks started here, it was a company that produced blanks. So a blank can be any shape object, but primarily it was used for cutting. So Corning is called the Crystal City because at one time there were about 20 different cutting shops that existed here in Corning. And they took glass blanks that were made in the factory by glassmakers, and then glass cutters would cut and carve away parts of that glass object and create a beautiful piece of cut crystal. And this is actually an example of one right here. So we've got a woman that's here with us from Austria, and she's been using our cutting lathe that's set up on our West Bridge. And this was a bowl that I tried my hand at. I made a little ruby bowl, and then I did some very simple straight line cuts here, and I measured it out as best I could, and it was pretty mediocre. I'm not really a glass cutter, but I gave it a shot. And then I handed it to Anna, and I said, "Can you work your magic with this?" And she's like, "Oh, yeah." And like 10 minutes later, she came back with this, and I was like, "Okay, that's pretty nice. That's okay." So it's absolutely stunning. It's really nice to see what somebody with a lot of skill can do with glass cutting. But that's cold work. It's not hot work. So it's actually taking more or less a saw, or not a saw, but like a diamond wheel or a stone wheel, and with a water drip on there and a lathe holding the object into that spinning wheel and carving into the object. The range of time to make some of the pieces on exhibit? Which exhibit? Oh, any of the pieces in the museum? It totally depends. That is a very broad question. So he's asked, what's the range of time to make any of the pieces in the exhibit? So any of the pieces in our museum, some of them might have been made within 30 minutes time. Some of them might have taken 3 years of time to really put together. It totally depends on what it is. It totally depends on what it is. That being said, though, if it's a hot worked object and you see something like, you know, this goblet, I think Jeff Mack, one of our full-time guys, made this. This is a beautiful goblet, and this probably took Jeff an hour to make. But Jeff's been blowing glass, I think, for about 25 years. So if you handed this assignment to somebody that's only been blowing glass for a year or two, they make a cup, but they're not going to make something like that nearly as nicely as that. So, and the same is true for Michael. You know, he's been blowing glass for 29 years. He's an excellent goblet maker too, and it just takes so many years of training to become good enough to do it. So we do a lot of demos at our museum every single day, and a standard demonstration for us is about a 15 to a 20-minute show. I always like to tell people at the end of the show, I'm saying, you watch that piece being made in about 20 minutes plus 15 years to be able to do it so nicely, and that is really the best way that I can word it to kind of get the point across. Because you don't see the first years of somebody's glass making where it's a mess, where everything is just a total mess. They can't turn the pipe, the glass is wobbling all over the place. It's horrible. But you have to go through that in the beginning and build your skill slowly to get to that point. Any other questions? Yeah. This is all by hand? Yeah, what we're doing here is all by hand, with the exception of this at the moment. They're using this. Production glass. Yeah, so, you know, windows, bottles, light bulbs, jars, almost all that is machine made now, yeah. At one time, it was all made by hand. And actually, in Corning, here in the very early 1900s, I think around 1908, they were making light bulbs, just cranking out light bulbs by hand. They had probably 30, 40, 50 glass makers in the factory floor, Corning Glassworks, just cranking out light bulbs by hand, one after another, trying to keep up with the demand. But that process was automated. The ribbon machine now produces light bulbs pretty fast. About 1,600 bulbs per minute are made with the ribbon machine. And it's literally a machine that just drips a hot glob into this ribbon mold, if you will, that is it's shooting sideways, and all these little gobs drop in this little hole, and they drip with gravity at just the right temperature, and they blow up with air, and you create this perfect light bulb shape out of them, and they just pump them out, just cranking them out. 1,600 per minute. Now, we could probably make one in 30 seconds, but that amount of, you know, it astonishes me to think about it. So yeah, automation has definitely changed the world with glass making, bottles, windows, light bulbs. The process has changed quite a bit too. So for windows, this is a good example. When windows were made by hand, they called those rondelles. So you could take a, you know, big gather glass, however much you needed for whatever size window you're going to make, and you just blow up a bubble, and you open it up into a bowl. So if you imagine, you know, like this shape over here, if you got this whole thing hot, you had a handle right here that you could hold on to it, and you're heating it, and you're churning it. You get this whole thing hot, and you keep turning, it flares open flat, perfectly flat, and that's a rondelle. So when you have a rondelle, you can then let it get cold. Oh, we have one right here. I wasn't even looking at it. This is a rondelle. And then you can cut window panes out of that. And with a giant rondelle, you can cut a bunch of windows out of there, you know, if you're making little small windows. So that's how it used to be done. Now, over time, that process has changed quite a bit. Nowadays, windows are glass that's cast on a bed of molten tin. So the tin and the molten glass do not stick to each other, but the tin, since it's molten, it's liquid, that glass ladles out or casts out onto the tin, and it's perfectly flat, and the surface tension just pours it right into whatever mold that's holding it, and it makes a nice, clean window. But there's a lot of different processes that were in between those 2 points, too. That's polar opposites of the timeline there. 2 questions from online.
So, with these thin threads on top, how do we stop it from getting cold too fast?
With these thin threads being applied on top, how do we stop it from shattering? Well, they haven't actually let the glass get to the point where it's too cold. So when the threads are going on right now, the gather that Josie has is probably around 15, 16, 1700 degrees. Michael's been keeping the core of his bubble more rigid, so closer to probably 1200, maybe 1100 degrees. But they never stay away from the heat for too long. Yeah. And once those wraps go onto the surface and they melt them down right now, they're not really thin anymore. They actually melt into the bubble that they have. So there's a lot of mass to hold the heat. I think that's probably what they were referring to.
And then this is really more of a question for Michael, but when he was first learning to blow glass, did he plan on it being his career, or was it just something he fell in love with and it ended up becoming his career?
That's a good question. Michael, we have a question from online for you. When you first started to learn how to blow glass, was this something you planned on as a career, or was this something that you sort of fell in love with at a certain point? Their words, not mine. Yep. Something that you stumbled into. And he's very, very gifted at it. So I think that it found him the right place. No one would knowingly plan this. Yeah, I will say that, you know, it takes so much dedication to learn glass making to the point where you can successfully make products like this, that you definitely have to have the drive to do so. It takes so much dedication to really learn it. And it is painful in the very beginning. Everything is very, very, very frustrating, extremely frustrating. But a lot of glassmakers will pick it up in college. That's a pretty common thing. There's universities, I think about 50 credited programs in the States with a Bachelor's of Fine Arts, a concentration in glassmaking. You can apprentice. Apprenticeships are a great way to learn skill. That being said, a lot of those automated processes now, you know, before there was a lot of machine-made glass, there were many more apprenticeships because you could find a factory job and you would become a glassmaker learning with a team or a shop that was there. So there probably aren't nearly as many apprenticeships now as there used to be, say, 100, 150 years ago. But certainly you can apprentice with a team. Some people will take you on and they'll teach you the way that they've learned how to blow glass. And there's workshops too, like Josie and Michael are teaching a workshop, a 2-week intensive class across the parking lot at our studio. Are you, anybody here in their class? Are you guys glassmakers? No? No. Or over there, excellent. You can always tell the glassmakers because they sit up here. They always sit behind the action. They got the whole bird's eye view of the shop. And we didn't have these monitors up until I think about a year ago. So those were installed and it's a wonderful addition. So what you guys are seeing, they can also see on these two screens up here. Monitors everywhere, 80-inch monitors surrounding us. I actually remember the first time that we had these installed and I was working in here, and you get this view right here, the inside our reheating furnace, and it looked like eyes that were just kind of like looking down on us because there was 2 of them. But this is such a fantastic view that we can offer you, that fused silica window. Very, very small window. You guys can see it if you look straight through. You can see that little port in the back, a window that's about 2 by 1 inch and shields our camera. So I think that's all the wrap that they're putting on there because I don't see any other wraps being heated. And I'm going to guess that Michael's going to take a dip of glass on this before he fills the cup. And he said he's going to gather glass on top of this once he gets the cup on there too. So this will be a pretty big piece. There's really no limit to how many gathers of glass you can take from that furnace until you either can't control it. It's right up front, so it's about as close to those steps as you can get. It's front middle, yep. When you come up here, it is like right here. It's as close to the wall as it can get. Yep. So here, that's what we call a price check. He's just looking, he sort of lined it up a little bit and said, okay, one, what position do I need to be in when I go up here, but also how much glass do I need to fill that comfortably. If you have too much glass, obviously you fill too much and it doesn't work right. If you don't have enough glass, you can still fill the cup, but then you're ending up wasting material. So there's definitely an ideal amount to get. And this is a one-shot deal too. Hot glass is very sticky to hot glass. We've seen that with the application of the wraps, right? The 2 surfaces stick together instantly. So when he goes to fill this cup, when he gets his gather of glass and he gets up on the steps and he goes to line it up, that glass is going to start to drip towards the ground because it's going to be hot enough to do so. And he's got literally just seconds to get it lined up and shoot for a bullseye. You just kind of dip it right into the center of the cup and fill it. And what you want to happen, what they would call this a stuffed cup, is for the tip of his gather to hit the very center bottom of the cup first. And then the rest of the gather fills from the bottom up. If it doesn't do that, say he attaches to the top of the cup first and then it fills downward, what happens? It traps air. It traps a lot of air in between the bottom of the cup and the gather, and that air does not come out. So it's very important to have the right shape gather, to have the right amount of glass, to have the right temperature, and very important to have it lined up nicely. So when we put that cup in there, I actually loaded that this morning. I did my best to get it positioned perfectly straight up and down, because if it's tilted offset, then you can't hit center either. So everything's got to be just right. But here's his gather. And sometimes we strip glass too. You might see him strip some of this into a bucket of water. Yep, right here. So if he doesn't want all that glass, he goes in and gets a nice even coating by turning multiple times. And then he comes out and he lets some of that glass just run right off into a bucket of water. And that bucket of water will break that glass into tiny little chunks. And we'll remelt that. That's all clear glass. We can reuse it. So he's going to cool this off. Each time you dip into that furnace, you do really heat up the pipe quite a bit more because you're dipping deeper and deeper into it. So usually after you're taking a big gather like that, you'll see whoever has the pipe cooled off. And we got the right pipes out too for the job. So before we started this, we actually said to Michael, took a look at a variety of pipes that we have here, and we said, what size do you need? What size pipes do you need? And you can see this is what we're going to do the work on the finishing side of things. This is a solid rod called a punty. We pulled this one out too because eventually we're going to break that bubble free from the blowpipe to work on the opening. More doors on that oven. We have multiple doors. There's actually 3 on that particular oven. And the idea is to keep them as closed up as you can to fit in and out of there, but to concentrate the heat better. But I think we're going for it right now. G is over there by the oven. That's our pickup oven. They've ramped that temperature up to about 1,000 degrees, which hopefully is just the right temperature. Great shot right here. Jason's getting a really good camera shot of this. Lines it up. You can see how that glass really starts to stretch away from the pipe, but it looked like he had it perfectly lined up. Filling it. Hands it off. Let's give him a big round of applause. Nice job. Beautiful work. Got a brush right there. So the very tip of that cup might have a little bit of residue on there. I don't see much on there. But the ring that it was sitting in was a fiber ring, good insulated material to hold it upright. And we're going to brush off any dust. So just using this little whisk broom. It looks pretty clean, but now's the time to do that. And again, this is transparent gray. The color is very rich right now. It's very dense. So it looks like it's opaque black, right? But it is a transparent gray. It's just very dense right now, meaning that once they inflate this to a pretty large volume, that transparency is going to show through. So now is everybody really understanding the interior of this are all those lines that we wrapped around in the white glass, and the exterior is going to be that transparent gray. Was it nickel? Nickel makes grays? Yes, we had a question up top here. What metal makes gray? Nickel, chromium can make gray. All different metal oxides and chlorides, and it has to be the oxide or the chloride of the metal. So one of our most expensive colors is ruby, and that's from gold chloride, and you can't just take like a gold ring, gold watch, throw it in the furnace, and poof, have pink glass. It's got to be the chloride. It's got to be a lot of chemistry to it to melting it down right. Yes, so Amanda and her team are going to get pictures of the final product when it comes out of the annealer, and we will post them on Instagram, Facebook, Twitter, no? Maybe Twitter too, Flickr? I don't have Flickr, no, not Flickr, okay. Does anybody follow us on Instagram, Corning Museum of Glass? You can also follow Michael and Josie Vetrovero. Goblet Ninja, I know is another one. That's Michael posts a lot of stuff on there on Instagram, Facebook. At Corning Museum of Glass, we like to post lots of stuff on there. And it does not matter what color it is, if it's gray, if it's white, if it's clear glass, purple, brown, pink, they all look bright orange. They all emit that same infrared light when they're really, really hot, and that just translates as orange. You'll see that orange come and go as we work through the process. Every time they take a reheat, it gets brighter orange. As it starts to lose heat, it loses that orange. It starts to dull. So now you can see that paper really starting to smoke and steam, and Josie is just there with that compressed air to blow the steam and smoke away from Michael's face. That's just for comfort. This shop actually was really, really well designed. We have great air handlers, and we call this our eyebrow to the shop. These actually push down if we wanted them to, but a lot of the air, the hot air, the exhaust, the smoke and whatnot, is getting drawn right up through the air handlers and pushed out right outside. So it's keeping the shop very comfortable too. We actually have floor vents. These little squares, these flip up this direction and AC comes out at us. It's a really nice feature. One more dip. One more gather of glass, he says, on this. So we've got a lot of material right now, but he wants enough material to make this size piece comfortably that he's after. And I can't remember if I talked about it or not. I think I did very, very beginning. They're going to use this dome, this mold, and you can see Josie is actually sprinkling some water onto it right now. That is a paper form. There's some type of interior structure to it, maybe wooden slats, I'm not sure, that's what I would guess. But there's basically just a paper dome on there. It's been burned, so we've got a lot of carbon on there. There might even be a little bit of wax mixed in, I don't know. But they're gonna create a bowl shape, get the bowl nice and hot, and then get it right on top of that dome and spin on that dome to get a perfect round form. These low bowls are really, really beautiful forms, and they're very challenging to make. But he's really smoothing out that cup. So when he stuffed the cup, he's now melting down the rim of the cup nicely to the moil there and getting everything just perfect for this next gather of glass. And he's squirting water onto the moil to cool it too, so that's just dropping the temperature quite a bit. So when he dipped that gather glass into the cup was rigid, right? That cup was, quote, cold. The gather was very, very hot. So he was reheating that to soften the cup and sort of melt it back down. The moil was really, really hot. So he kind of balanced the temperatures out a little bit by cooling down the backside of that. All right. So we're getting ready for that final gather. And what G is doing over there, G has a metal rake. He's skimming the surface of that glass. Can we roll that gathering animation? This would be a really good time, actually. So this, thank you very much. This is what we're doing when we go to gather glass. You can't see through the side of our oven, but if you could, this is what you'd see. So that's the ceramic pot, that crucible that holds our glass. And we dip the bubble right into that molten glass. Now, as we gather, you can see that some of that glass kind of trails off. It breaks off from the gather, or just drips off from the gather. In that process, sometimes bubbles form on the surface of the glass. And if you dip this beautiful bubble, this cup and all that wrap in there that we've just tried to avoid getting bubbles into the glass, and you touch bubbles in there, you get bubbles in the glass. Now, there's ways to get those bubbles out, but if you get a bubble right on the surface of the color, it's going to disturb the color. So we just skim the top back with that rake and push any bubbles that might be there out of the way. It's a nice thing to do, especially when you've invested all this effort into making this a nice, clean setup for that. Big blocks. We got you some other ones, too. They're over there that have handles on them. We have all these blocks on the ready. All right, here we go. I think you'll be impressed with this. This is always fun to see this amount of glass come out of that oven. Michael's very careful, too, not to touch the door, too, because the door, the arch of that oven is quite hot, obviously 2,100 degrees, and glass would stick right to it. So dripping off some of that excess, Josie is shielding Michael from all that heat. That is putting off a significant amount of heat, all that glass, and straight to the pipe cool. Can you see where he's holding the pipe right there? Right about in the middle, right? And you can see how much he was putting his body into holding it up. Now when they cool it, they'll be able to really change that fulcrum point and get so much more leverage on it. Makes it much, much more comfortable to manage. But I say we give him a round of applause because that was pretty impressive. Nice, nice fresh gather of glass. And of course, the first thing we want to do with a fresh gather around that core is get everything even. You want a nice, even distribution. So we're shaping this up in our block, this really large cherry wood block. It's very similar to the way that a potter works on the potter's wheel. When they throw a slab of clay on the wheel spins. The clay needs to be centered before they can effectively shape it. And they can do that with their hands. We can't. So we use all these tools as extensions of ourselves. But centering I almost said clay, centering the glass on the blowpipe. Now, one thing you're going to see them do eventually here, once they start to inflate this a little bit, is create what's called a jack line. And I'm going to show you. We've got a lot of these up here. These are called jacks. And if you took basically just two really large butter knives, welded them to a sprung steel handle like this, that's pretty much in a nutshell what this tool is. And these aren't real sharp. Again, it's like a butter knife. But these blades are used primarily to squeeze over top of the glass and create a constriction. We need to remove this bubble from the pipe when the time comes. So we're going to create a jack line so we can break it free. But this is pretty common now. We've got a lot of glass on the end of the pipe, and each time it gets hot, when we reheat it, the whole thing starts to move around. Gravity's pull feels much, much greater on it, so we have to apply a lot of torque to keep everything running on center. So it's nice to have the team jump in and do the turning while the gaffer sits at the bench and sort of instructs the team. So that's what G has been doing. G has been really kind of handling the pipe here, taking reheats, shaping it up a little bit. But this is all on Michael's command, right? And so in this case, Michael's taking over the heat. But really, the team jumping in to really help carry the weight of this item. You'll see some shielding happening. Josie was doing that earlier, but as we get closer to the glass, especially the larger this object gets and all that heat that it's emitting, we'll jump in with some wooden boards and shield the Glassmaker. So now he is starting to use the Marver as a heat sink. Remember I was talking about this earlier. The metal draws temperature from the glass very, very quickly. And using it to just cool one area, so one half of that bubble. Now envision this. The part that's attached to the pipe, that's going to turn into the top of the form. The tip of the bubble is going to be the bottom of the form. And it makes sense to have some extra thickness in the bottom of the form. So he can cool that area before inflating it and keep that area a little thicker than the rest. Temperature management. You can even see the temperature difference, right? See where it's a little bit darker orange near the blowpipe? That's where the glass isn't as hot as the other areas, so cooling those other areas first. The pipe also, being metal, is always drawing heat from that side of the bubble. It's also the last part in the oven and the first part to exit that oven. So naturally, that part just doesn't get as much heat throughout the process. We can help balance that by cooling it. We can also help balance it sometimes by torching it, too. We might torch the other side and increase the temperature a few hundred degrees more. Sometimes that's an effective way to do it. But Michael's put on a big Kevlar sleeve here. A good material, very well insulated material. Kevlar and cotton. Cotton is the clothing you definitely want to have in a hot shop. You don't want to wear anything like fleece, rayon, any plastics that would melt. So now G is turning, Michael is shaping, Josie is shielding, and Ryan is inflating. This is a great team shot right here. Everybody working in sync to make this go very smoothly. And you can hear, I could hear Michael giving commands too. He says, blow Ryan, stop. Sometimes we say blow lighter, blow harder, keep going. Yeah, so here's using a torch. Josie's now using a propane torch to heat up that one area that's going to turn into that jack line. That's where we're going to install the constriction to break this bubble free. And when they go to squeeze this jack line in, I don't know if he's going to do it this heat or not, it takes a lot of torque to keep the pipe turning as soon as they start to squeeze those blades together. What's up?
What temperature does the fluffy torch?
That fluffy torch is probably right around, I don't know, 1600 degrees. Yep. We have a hot torch, too, that runs on oxygen and gas, and that will get up closer to 3,000, maybe even 3,500 Fahrenheit. I don't know if they'll use it for this particular piece. But again, inflating while Michael is shaping, and he's really holding that paper in places he doesn't want the bubble to blow out. You can always reheat and inflate more and stretch the glass thinner, but if you go thinner than you want, it's very, very hard to compress it and thicken it again. So taking their time here and not really just blowing it up all in one shot. Getting the heat just right, inflating it in the areas they need to. You can see that Dane is managing the doors over there. Opening and closing our reheating oven. You don't want to just leave the doors open because that heat will drop quite a bit. And it makes it harder for G to get the heat in the glass the way that he needs to. Yeah, so this next move is where they're going to start forming the jack line, I'm assuming. Glove? Yep. Because Michael has just heated up his jacks. And the jacks work best when they've been preheated with a little bit of beeswax applied to them. Because the metal creates a lot of friction if it was just bare metal. So the wax is perfect because at room temperature, the wax clings to the blade, but then it starts to heat up and it becomes very slick. It's like oil. So look at this. Watch how much torque. G is really cranking that pipe to keep things moving because that tool is acting like a brake. He is squeezing those blades together so hard over the bubble to form a proper line, but it means that G has to really crank on that blowhole pipe to keep things going. So that was a really nice move. So the more concise that jack line is, the better off we'll be. Because when we go to break this from the blowpipe, we want to break it clean at that line. So if that line isn't well established, if it's not that sharp, sometimes you can take a chunk right out of the side of the bubble when you break it free. Glass is really finicky. It does not like to break in a very clean line, so we have to force it to. We have to tell it right where to break. So actually, while they're going through the setup here to get this inflated just right, this is color rod. So I was talking about this earlier. I was showing everybody kind of a marbleized color rod. But what color does that look like? Looks black, right? This is a nice light blue. It's a very light, transparent blue, but it's just in its condensed form right here. So this color rod, this comes from a factory over in Germany. No, this one's actually Gaffer Glass. This is a company in New Zealand. But this is enough blue to make at least one, maybe two of these vessels. So if you put this onto an end of a blowpipe and gather layers and layers of clear glass over it and inflated it, this stretches and eventually it would wash out into that blue. If you use too little, it washes out too much. If you use too much, then it stays too dense and it appears black or too dark. But there are a couple hundred different colors: transparents, translucents, opaques. There are reducing colors. There's lots of fun stuff to work with. But one of the factories that we buy ours from is Reichenbach. That's been around for, I think, about 200 years now over in Germany. So continuing just to get the nice round form, a nice even blowout. You can start to see through it now, that transparency of that gray.
thought they were going to punty, but
Last time my band was working on it. Then you got a little bit more out.
yeah, I think I got this. Yep.
So at this point, even just heating and turning the blowpipe can affect the shape. Holding it up in the air can affect the shape. Holding it to the ground can affect the shape. So really using gravity to his favor now. And for creating a bowl, this is a really common move. This is called settling back and just allowing gravity to compress and widen that form. And a very important thing that Michael did before holding it in the air, did anybody catch it? He capped the back of the pipe with his hand. That trapped air pressure in the piece. So it kept the same volume, but most importantly, it didn't let the bubble cave in. Because if you hold it up in the air without capping the pipe, then it caves in. And if it caves in too far, it can actually touch together, and then you don't have a nice bubble anymore. So a very difficult move to do right, especially with a lot of glass like that. Yeah?
I really like this one. What is a glass blower / artist's favorite challenge to overcome? What has given a memorable sense of satisfaction?
What's a glass blower's greatest challenge to overcome? Glass blower's artist's favorite challenge to overcome. What has given a memorable sense of satisfaction? When a piece comes off the pipe and the punty and it's still intact. I think that's really satisfying. I think a lot of glass blowers will tell you that they're constantly trying to make a better and better piece each time they make something. I know, personally speaking, anything I make, I could pick out 100 mistakes to it. So trying to always create something nicer, better, just really paying very, very close attention to it as we work with it as well. So we're getting pretty close, I think, to transferring this piece. When we go to remove this from the pipe, what we're going to use is a handle called a punty. We're going to attach it to the tip of the bubble. And that punty is just some glass that's gathered and shaped on the end of a solid rod. That rod that I actually pulled out and showed everybody, that's going to be the punty that we'll use. And then we'll break this free from the constriction from the blowpipe, and that will produce a very small opening. Then that opening will be reheated and stretched open wider and wider. And then when we get to the point where they have the setup right, we're going to use that big dome mold to create the final shape. And I haven't actually seen this one in action. How many times have you used that, Michael, that dome?
Half a dozen, maybe 8.
Half a dozen times, about 8, 10 times, he said. Okay, so it looks like Josie's going to make the punty. And Michael has a piece of chalk here. I think he's going to draw a bullseye, maybe. When you go to attach the punty, you really want it to be placed as close to center as you can get. And you can adjust it when it goes on if you need to. But he's marking himself a nice little bullseye, a target, to place that punty onto. And that chalk will just wipe away. Or this piece will probably actually be ground when it's all done. You can grind this on a wheel with grit and flatten it off. So while Josie's making the punty, they're really just balancing the temperatures out. The bottom, what's going to become the bottom of this bowl, has quite a bit more heat than the rest because there's a lot more mass there. There's much more thickness there. So they want that thickness, they want that heat to dissipate to the point where that bottom's rigid, motionless, not soft anymore. But they need to keep the other sections warm enough. So they can take quick reheats, but they can use that torch to keep certain areas warm, but really just keeping the perfect temperature. This is such a tricky move in glass, this transfer that we're about to do, because if your temperatures are off, then bad things can happen. If this bubble's too warm, when you go to attach the punty, the bubble can lose its center, it can distort its shape. If it's not warm enough, though, and you go to break it from the blowpipe, we all know what happens, right? The glass can crack or shatter. So it's got to be just the right temperature. And this is where the skill and experience just comes into play. So Josie's got one gather on there. She's going for another one. This will probably be the final gather for the punty. It's what we call a cold core. So she has a layer of glass that she let get pretty rigid on the interior of this fresh gather, and we'll use the fresh heat once she shapes this up to attach firmly in place to the bottom of the bowl. And once this gets attached, you will probably see Michael create another very quick constriction line between the punty and the bowl, so ultimately we can break it free from the punty in the end too. Not only do we need this attachment to be stable and stick to the bowl, but we need it ultimately to break free in the end. Of course, cooling the punty, making it much easier, more comfortable to handle. And they were communicating right there. It was very subtle, but they gave a little look at each other, you know, a little nod of the head, confirmation, yes, I'm ready, okay. This has to come together at just the right moment. She's getting a little bit of heat on that punty. Here we go. So making just the right connection, and here he goes again with his tools, his jacks, and squeezing down into the glass that's on the punty in between the bowl and the punty rod that Josie has. So just making this constriction. This is going to allow them to break it free right there at the end. Now that the connection's established and on center, Ryan is blowing just a bit of air onto it to cool it slightly, and that stiffens it up. Because right now, that connection is really, really soft. And if we broke it free from the blowpipe, it's so soft right there that it would be really wobbly and very, very hard to control. So just a little bit of air, and watch this. Wait for it. A nice tap. It breaks it free. And she gets it right up to the yoke and gets it up to the oven. It's okay. Gets it up there, and up to the oven we go. Let's give him a big round of applause for that move. Really, really difficult to do. And she manages it nicely. You can see how much that's moving. But getting it right up to the oven at that point is very important, at least just for a very quick reheat. That's about as cold as we want the piece to get through the process, that transfer. So just a quick little straightening up here, making sure everything is on center. He can get his tweezers into the opening, and if he sees that the bubble is kind of going up and down, the high side, you stop with the tweezers in the opening, and you let the punty sort of settle a little bit, and that's just a centering move. You want to get it centered now because that punty connection will actually firm up pretty soon. So now you can see we have developed a very small opening. We just have to reheat it, re-soften the glass, and start to stretch that opening wider. And Michael, I believe, is going to trim some material off from the lip of the form. So you can see two different types of shears that we have here. He's actually got a pair of what's called duckbill shears. But these are straight shears. I think everybody probably has something like that at home, right, if you can see them. Good for cutting cardboard or paper. But these are called diamond shears. Now, he hasn't really used the diamond shears in this process, but if we were doing any type of bit work, like putting a handle on a piece or something like that, you can use the diamond shears, which the diamond just refers to the blades that come together. Those bent shape creates that diamond aperture, and it cuts the glass to a very, very small point, whereas straight shears will cut to a straight point, or in the case of trimming around a bowl, the straight shears are necessary, or the duckbills he's going to use. But it's easy to cut through glass as long as it's hot enough. Very soft. Very, very soft, as long as the temperature's right. And we can cut through the lip. We can remove some of the lip to do one of a few things, really. If the break-off was a little uneven, you can cut around it and make it even in doing so. You can remove some excess thickness that has built up through the process of getting it off the pipe. Or you can remove some material to shorten the dimensions of the bowl. And that's a common thing to do with a lower bowl like this, is remove some glass so you don't have as much material to widen out into that low curved form. But first, it looks like he's going to pinch and pull the lip a little bit. So G's got a nice heat on there. Good heat. Great shot on the cameras here too. If you look, you can see a really good heat line, right? And that's very important. If G was heating too deep in that furnace, then a lot of that bubble would be hot and moving right now and be very hard to control. So getting the heat position just where he needs it, really, really important. Look at that. Nicely done. And working together, too, to do that properly. G was, in charge of churning, and I could hear Michael saying slower, move just a little bit slower to keep him in sync. Because if you move too fast when you're trimming, your shears end up getting bound up here. If you're not turning fast enough, then you get too far ahead. Just right. Also, when we work on this punty, that connection to the punty is very small. It's very small for a reason, right? We want it to break free with no trouble in the end. But each time G moves around with that punty, when he goes back and forth, sets it down on the bench rail or the rollers up there, he's very careful with it. He doesn't just slam it down. Any excessive vibration can cause that connection to snap free. So we got to be really, really light-handed with it. Even though it's a very heavy piece and you have to really apply a lot of torque to keep things moving right, you have to be very gentle with it. He also keeps the punty hot, too. Watch when he goes back up to the oven. I'll talk about when he does it. But starting to open this up now. Josie is on standby with that poured. She's protecting Michael's hands, but she can also paddle the lip if it needs it. But mostly just shielding his hands and paddling the lip at the same time. Keeping the lip straight as well as thickening just a touch right there. So when G goes up to the oven, you'll see he takes it up to the furnace. He goes deep inside the reheating oven for just a little bit of time. They actually close up the doors for a little bit too. This is called a flash heat, and that's mainly to keep the bottom of the bowl and the punty warm enough so they don't crack or break. But then he can back out and kind of soak the temperature just on the parts he needs to really get hot. And there are two burners. I mentioned there's two burners firing into there. So we know from reheating out of that oven every single day, day in and day out, where the hot spots are in that furnace. So depending on how far in or out you go, you get that bubble position right in front of the burners and get the heat that you're looking for. The longer you stay in there, the hotter the glass gets. And with a bowl like this, it's really important that we turn very slowly. Because if he got this whole thing hot and he was turning fast, the hottest parts start to flare out. And we don't want this to flare out. We want this to stay a nice, low, curved bowl. So you have to exercise a lot of control in your heats and the turning. In that case, using the torch to just kick up the temperature a little bit on that bottom shoulder section of the bowl to get that moving a little bit too, just to help it move a little bit too. So I think Josie is actually putting a little bit of wax onto that dome. She's heating up a little cake of beeswax on there. That wax is going to stop the bowl from sticking to the paper dome when the time comes. So Michael's now using a tool called parchofis. These are two cherry wood dowels. They've been attached to that metal head of the tool. It's a great shot right there. Really shows you just how hot the glass is, right? And remember, at 1,000 degrees, this glass is totally rigid. It's unshapeable. So if you see any movement to it, if we're doing any shaping to it, it's way above 1,000 degrees, probably closer to 1,500. But again, the jacks, the metal jacks, and then the wood jacks, or the parchofis. Same type of head to the tool, sprung steel, but cherry wood dowels that have been attached in here. And the wood is nice at this point. One, the jack blades are very sharp on the tips, so if you were trying to push in and open that bowl like that, the tips are going to scratch the interior of the bowl. The wood is rounded at the end, so you can really get in there and shape with it and not harm the interior at all. So we're getting pretty close to using that dome mold for this form, and they're setting up those steps. So whoever is on the punty can jump up on those steps, just like Michael did earlier to stuff the cup. Get him in the right position. So Jason's going to get a really good camera shot when the time actually comes for this.
He's going to help Michael turn.
Okay. I'll shield.
And making a low bowl form like this with no bump in the sides of it or no dip in the sides is so challenging. And much of that has to do with the setup. So when they were blowing this bubble up, when he was inflating it, he's really making sure that everything was inflating nice and evenly. That's very important. But also the reheats that G was taking, if those heats weren't the right heats, one area is too hot compared to another, that area wants to move, and that's when you can create a dip in the form or a bump in the shoulder. So keeping a nice rounded form. So I think this is where he's going for it. He's talking to the team over there, telling him what he needs, but he'll get this really, really hot. And Josie actually has some cork paddles in her hand. I think she's going to use, yeah, look at this. Gets it nice and hot. He could spin that into a plate right now, but he gets it real hot, gets right on the center of that form, and he's going to turn really aggressively. G's ready to help him turn. What you need?
Okay, everybody just turn easy. Yep. Nice and easy. Take your time. Hit the lip again, Josie.
So continuing to turn, Josie's holding the cork paddles on the edge of the bowl, and we get this beautiful form. Give him a big round of applause. An excellent shape produced. All right, so Ryan is gearing up. Yep, the ring is right in the middle. So a beautiful, absolutely beautiful bowl shape produced. And Ryan's got Kevlar gloves. He's got an aluminized jacket on, too. We'll give him a face shield. He's going to grab this piece, and he's going to lean down into a 900-degree annealer. Over here, buddy. Over here. And he's actually turning the bowl, too, before he goes in, because that is still a little bit warm to the point where it could slump. We'll close this up safe and sound. Let's give it up. Big round of applause for these guys. That's Michael Schunke Josie Gluck. And a gorgeous, absolutely stunning piece of glass. Whew. And a wonderful finale, too, going on the mold. Wow, absolutely beautiful. You're very welcome. Awesome job. The whole team here as well, Ryan, G. Bryan, and Dane. Beautiful work.